Hi, today in this quick session on direct and inverse variation, let us try to understand and solve some of the complex problems of direct and inverse variation. Since this is a short video, I'll be quick here. And a quick thing, right? A direct proportion and what is an inverse proportion. A quick introduction so that we understand it, right? In 1 hour, the car travels 20 miles, right? So essentially in 2 hours, it should travel 40 miles. So it's a direct proportion, 1 hour 20 miles, 2 hour 40 miles. Absolutely direct proportion. So which means it is proportionately increasing. But what is an inverse proportional? Uh, five people can finish a job in, let's say, 10 days. If you deploy, let's say, 2 people, will the number of days go up or will number of days go down, right? Then actually the number of days will go up because the work will remain the same. So number of people have decreased, the number of days have increased. These arrows will tell you that we are actually talking about inverse proportion. So if we are clear with direct and inverse, we'll quickly jump to those complex problems of direct and inverse variation. Now let's look at this question, and I'm particularly taking this question because the number of variables are more. And what are variables? Let's look at this question. 24 laborers working for 6 hours. So variable number 1, the laborers, the hours, can finish a piece of work in 14 days, right? So you see there are 3 things. One is the laborers, the second is the hours, and the third one is days. We don't care how many variables you keep adding. We will be able to do this in the most simplistic fashion. They're asking if each labor works for 7 hours a day, find the number of laborers required to finish the same piece of work in 8 days. Let's articulate it, right? And let's quickly draw, and I will explain you in a very quick fashion which will help you to solve it. Let's say laborers, hours, and days. You just write it in this fashion and create a matrix, right? Let's look at case number 1. And this is case number 2. The case number 1. They're asking 24 laborers, if they work for 6 hours a day, can finish a piece of work in 14 days. Brilliant. If each of the laborer works for 7 hours a day, the same piece of work, which means if they were to paint a wall or build a house, the same piece of the work in 8 days, will you need more laborers or less laborers? This is your second construct. Now some people find it very difficult to solve, but I'll tell you a very simple way to do it. Now let's consider this option as X, right? And the way you solve it is, right, this is where what you need to find. If you need to find this, then what you need to compare with laborers with hours, and you need to compare laborers with days. Let's look at that. Since you are finding this column, so you will write this as 24 by X. Whatever you need to find, you will write it as this, right? Is equal to, always, right? Now you compare laborers with hours. Imagine when I say compare, just leave days in isolation, don't even look at it. If 24 laborers are required working for 6 hours a day, if the number of hours are going up in this case, will the number of laborers go up or the number of laborers will go down? See, if the number of hours are more with us, that means we will need less laborers to finish that work. I'm saying don't even look at days, forget days. What does that mean? This is incomplete inverse proportion. Since lab and hours are in inverse proportion, and hence instead of writing this as 6 by 7, we write it as 7 by 6. Why? Because it is inverse proportion. Had that been direct proportion, we would have written it as 6 by 7. Okay, now let's compare lab with number of days. 24 people, which is laborers, 24 laborers will need 14 days to finish the job. If the number of days are going down, don't even look at hours. Don't even look at it. It's in isolation. We are talking only about days and laborers. If the number of days are going down, that means your number of laborers will go up. because the same quantity of work or the amount of work that you need to do in lesser time, the number of people have to be deployed are more. And hence, here again it is an inverse relationship, and instead of writing the direct relationship of 14 by 8, since the relationship between laborers and days is inverse, we write it as 8 by 14. If you solve this for x, you will get the answer as 36. Let's look at another example of this, and it's talking about a variable which is called as typist. Then you're talking about hours and you're talking about days. So what are the talking about? So let me write those variable typists. Then we are talking about hours and we are talking about days. Right now, let's look at this. They are saying if there are 14 typists working 6 hours a day, they take 12 days to finish a piece of work, and the piece of work could be writing as good as 100 books. I don't know how many books are they talking about or what are they talking about, right? To type a manuscript in this case. Now they're saying if the situation changes and if there are only 4 typists available to us and 10 are no more there with us, there are only 4 and they work just for 7 hours a day. So how many days should we finish the work? Right? This is a quick question and you need to find the answer. Sometimes we find the answering this very difficult, but it's very simple. Again, by the same logic. What is that you need to find here are the number of days, right? And you need to know that by this table, what you need to find is this. You keep it on the left hand side, 12 by x. Now, the first thing that you do is to compare typist with days. You don't even look at the number of hours. 14 typists will need 12 days. If there are 4 typists to do the same piece of work, will they take more days or less days? See, the number of typists are going down, so the number of days should go up. The arrows are absolutely inverted, and since they are inverted, they are in inverse proportion, and since they are in inverse proportion, and hence, instead of writing this as 14 by 4, we write this as 4 by 14. Now, let us compare hours and days in isolation, and don't even think and look at typist as a whole, just look at hours and days. If you work for 6 hours a day, you have 12 days to finish the work. So number of hours are going up to 7 and the number of days are going down because the number of hours per day have gone up. That means we will need less than 12 days to finish this work, and hence I say this is an inverse proportion. And since this is an inverse proportion, instead of writing this by 6 by 7, I write this as 7 by 6. Again, if you solve, you get the answer as 36, right? And there is where your answer lies, that the 36 days is what you will take to finish the work if you deploy 4 typists for 7 hours a day to finish a piece of work which is nothing but to type a manuscript of a book. Okay, let's look at this example now. It says the variables. You're talking about wages, laborers and days, right? So let's look at the first construct. If the wages of 15 laborers who work for 6 days is 8,100 rupees or dollars, whatever you like. Right? Find the wages of 21 laborers who work for 5 days, and they are asking us to find the wages. So by the same logic what we did it earlier, whatever I need to find are the wages. That means I put this as 8100 by x is equal to. Now let's compare laborers with wages in isolation. Don't look at number of days. If you deploy 15 laborers, the wage is 8,100. If you deploy 21 laborers, will the wage be more? The number of laborers have gone up and the number of wages will also go up. What does that mean? It's in direct proportion. So which means if it's direct proportion, I'll write it as 15 by 21 into. Now you compare days with wages. Don't look at laborers at all. If the number of days is 6, the wages is 8,100, right? If the number of days is going down, will the wages will go up or down? It will actually go down. Is it in direct proportion or inverse proportion? It's actually direct proportion. Look, both the arrows are in the same direction. So it's in the direct proportion. So I will say that we'll multiply by 6 by 5, right? If you solve for this, the answer for x comes to rupees 9450. What does that mean? Which means if you deploy 21 laborers for 5 days, the expense is 9450, right? Which is certainly more than that. But I hope you got the construct of solving these. So it really doesn't matter how many variables you have, which is laborers, days, wages, toys. You keep adding to it. You just follow the same logic. Whatever you need to find, you keep it on the left hand side. Rest individually you keep comparing with whatever you need to find. In this case, laborers we compare with wages, and days we compare with wages. All the best and do good. Thank you.